Hello, seventh graders! I hope this message finds you well. I hope you guys are healthy, happy, and feeling okay about our home learning. As always, if there's anything you need, please reach out. I am here to help. All right. Today we're moving on with lesson 7.1.3. It's all about solving problems that involve percents. So far, we've been talking about how there's many different ways to solve the same problem. Today, we're going to look at more than one way to solve a percent problem. So in the Google Classroom, there should be a document, a Google Doc that has all the questions for today. I'm going to be reading through them and then explaining them. So here we go. So the first problem, we have Hugo and his family, and they're shopping, and they purchased a new bed. The bed was a great deal, and it was 60% off of the original cost. The original cost of the bed was $245. Your job, and so we've solved these type of problems before. This one's not new. We've drew diagrams to solve these. We also set up proportions, but what I want you to do is draw a diagram for this problem. And then answer the questions. If Hugo scales or multiplies the original cost of the bed by 60%, what will that result represent? And then what should he multiply the original cost of the bed by to find the new price of the bed, or how much he'll pay for the bed? And then I do want you to look for two different ways to solve this problem. Okay? So, the diagram. I'm going to show you what I have here. Somewhere. Okay. So here's what we have. The original cost of the bed, $245. Okay. It says that it's 60% off. So the discount is the 60% here. That means he's going to pay 40%. That's the sale price here. So this is a diagram that you could have made. Now, if he scales the original price of the bed by 60%, that's the 60% goes with the discount. That's how much he will save, right? So what should he scale or multiply the original cost by? So here's where we have two ways to do this. So this kind of skips ahead to example or part D too. So if he's going to save 60%, he's going to pay 40%. So what you can do is you can take 40%, which is 0.4 as a decimal, and you can multiply it by 245. That gives you $98. That solves this problem in one step, okay? Or you can also use the multiplier 0.6. 0.6 is the discount, okay? So if you take 0.6 and you multiply it by 245, you get 147. That represents the discount or the amount he's saving. So we're not done if we use 0.6 as a multiplier. Instead, what we have to do is take that, we have to take the original cost of the bed, $245, and we have to subtract that discount, which we found to be $147. That gives us $98 as the sale price, and that's what we got in the first one. So this is two ways to solve by using two different multipliers. The first example accomplishes it in one step by using the multiplier 0.4, which is the percent of the bed that he's going to have to pay for. The second example uses the discount percent, and then that adds an extra step. Okay, so that is question one. Question two, Hugo's older sister, Sandra, had the same summer job for the past 2 years. Last year, she worked the entire summer and was paid a salary of $3,000. This summer, she's going to get a 6% raise in pay. So to figure this out, she drew this diagram here. Okay. Here is the diagram. Okay. So last summer, she made a wage. That wage was $3,000. She's going to get 6% more. Okay, so she's going to make everything she made last summer and more. So there's that diagram. Then it says, since Sandra's salary is increasing, does it make sense that her scale factor or multiplier should be less than 1, equal to 1, or more than 1? Okay. The diagram also shows her original salary and the amount of the increase. What's the scale factor or the multiplier between her original salary and her new salary? Or what number could Sandra multiply the original salary by to get the new salary? And then also, just like we just did in the first problem, come up with 2 different ways using 2 different multipliers so that she can compute her new salary. So this is what we got, okay? The diagram, 3,000 plus this 6% plus 6% of 3,000 gives her her new salary. So we're looking for 6% of 3,000. That represents her raise. So that equals $180. Remember, the way we can do this, 0.6 or 0.06 is 6% times 3,000. When we multiply decimals, all we do is take the decimal out, multiply the whole numbers, and then put them back in. So you can take 6 times 3,000, right? And then you get 18,000, and then you have to put the decimal place 2 in, which brings you to $180. So that represents the amount she's getting in addition to what she made last summer. So she's making $180 more than she did last summer. So you have to add 3,000 plus her raise of $180, and you get her new salary, which is $3,180. Okay, that's one way to do it, by using the multiplier 0.06, and then you have to do that in 2 steps. You have to add that rate, the 180 to 3,000. You can also do this problem in 1 step, which is the second way I'm going to tell you how to solve this problem. You can use the multiplier of 1.06. That represents 106%. Okay, you could multiply 1.06 by 3,000, and again, you get the same answer of 3,180, but you accomplish this problem in 1 fewer step. Okay, whichever one you like better, you can do, you do get the same answer. Okay. Question 3. Okay, now we have Marana, and she teaches gymnastic lessons at a summer camp. She is paid $12.50 per hour. She is offered a raise of 100% per hour. What would be her new salary? What percent of her original pay would she be paid? And then that was A. B says if she's offered a raise of 75% of her hourly rate to teach a private lesson, how much more per hour would she be paid? Or what percent of her original pay would she get? And then C says, what is the relationship between the percent raise that Marana gets and her new pay as a percent of her original pay? Okay, so we're going to solve these problems now. So we have A. So she's getting a raise of 100%. That's a pretty good raise, right? This is what she was making. This is her raise amount. So she's making 200% of what she made at summer camp. So 200% as a multiplier is 2. Right? So you can take $12.50 and multiply it by 2 to get $25. So in A, it's $25. Part B, she's offered a raise of 75% of her hourly rate. So she's getting a raise of 75%. You can take 0.75 and multiply it by $12.50. So that ended up being $9 or 9.375. We go ahead and round that to $9.38. So that's how much she's getting a raise. So she's not, okay, think about this now. If someone says you're getting a 75% raise, you were making $12.50, and now your new wage is $9.38. That doesn't sound right, because you have to add that to the $12.50 to get your new rate of $21.88. Okay, one way to do it. Second way to do it is take the multiplier of 1.75, the 1 representing the 100% that you're keeping, the 0.75 representing the 75% raise. So the new multiplier could be 1.75, and you multiply that by $12.50, which was her hourly pay, and you end up with $21.88. Okay, 2 different multipliers, same answer. Okay, then last problem. Liam was working on a problem, and he drew a diagram like the one below. Then he wrote the equation, $72 multiplied by 0.14, okay, which represents 14%, and that equals X. Does this equation agree with this diagram? Okay, if you agree, solve for X. If you disagree, write and solve a new equation to be able to find X. So we're going to solve this last question. So here's the diagram. Okay, Now, is X representing the 14%? Okay, that answer is no. Okay, 14% is over here. X, which is right here, represents what percent? Well, 86%. So the equation that we should be solving, well, X is equal to 86% of 72. Okay, so we have to take 0.86 and we have to multiply it by 72. And the answer should be $61.92. Okay, so I hope that worked out for you. If you have any questions about this lesson, send me a chat, send me an email. We can set up a video chatting opportunity between us. Whatever works best for you, I'm open to, okay? I'm here to help, okay? And we'll talk soon. Okay, have a good day. Bye, 7th graders.